Alrighty, so there are a few tests that we can do to check whether two triangles are similar. So they are the SSS, the SAS, and the AA test. I usually just call it the AAA test, but technically you only need two A's to do it. So what do S and A stand for? Well, S stands for side, and A stands for angle. So this is really the side, this is the side angle side, and this is the angle. And what we're saying is we're looking for things to match. Now, for two triangles to match, that does not necessarily mean that they should have the same sides. And in fact, using scale factor, they probably shouldn't have the same sides. So what does that mean? Well, it means that the K value for matching sides is the same. So if I've got 6, 7, and 8 over here, and I've got 12, 14, and 16, well, we can see that the K value for each set is going to be the same. 16 divided by 8 is 2. 14 divided by 7 is 2. And 12 divided by 6 is 2. So the scale factor for all three of them are the same, meaning they pass the side test, meaning these two triangles are congruent. But imagine for a second that even one of these was wrong. Let's change this to a 15. Well, that means that the first one would have given us 15 on 8, which is not equal to 2. Therefore, it fails one of the sides, which means it fails the side test. Now, the side test can also work for larger shapes. You just add more sides. So as many sides as there are, if you're dealing with a 4-sided shape, you need to test all 4 sides. If you're dealing with a 5-sided shape, you test all 5. The next one is specific for triangles, and this is the side angle side. Now, it's specifically the side angle side for a reason, because what it says is that if the two sides match and the angle matches. Now, unlike with the other one, the angle has to be exactly the same. So not only do the two sides need to match, but the angles need to be exactly the same. So in this case, we've got 20 degrees and 20 degrees, and we'll say it's 5 centimeters on one, we'll say 5 on one side and 12 on the other. And we'll say that it has increased to 8, and we'll say that 12 increased to 19.2. And we can ask the question, well, are these actually similar triangles? Well, let's test. So the first matching pair we have is we've got 8 over 5, which gives us 1.6. And now we're hoping that this is also going to work for the 19.2 over 12. And in this case, it does work. It's also 1.6. But for the side angle side to work, the angle that matches needs to be in between the two sides that we are comparing. It's side angle side after all. Side angle side. The angle is smooshed between the two sides. It's the only way the rule works. And in this case, we do actually have a matching angle. Therefore, these are also going to be similar by SAS. Now the last one is the R proof. Now the R proof works by checking that two of the angles are the same. Because for a triangle, if two of the angles are the same, that means that all of the sides are going to be the same as well. And for larger shapes, it works exactly the same. It's always the number of angles minus 1. So you can always, as long as you can check that nearly all of them match, then you should be good to go. So let's say we've got 15, not 15, let's make this 40 degrees. We'll say that this is 100 degrees. And then on this triangle, we'll say that this is 40 degrees. And we'll say this is 40 degrees. And you go, well, doesn't work. They're not similar. Because, this one has 40 and 100, and this one has 40 and 40. And they don't match, so therefore they can't be the same. However, we can actually show what the last angle should be. And if we remember, a triangle's angles add up to 180. So if we take 180, subtract off 100, subtract off 40, we get 40. And similarly for this one down here, we can do the exact same thing. We can do 180 minus 40, minus 40. And we're left with 100 degrees in the middle here. And so now we can see that actually all of the angles do match. And so by the AAA, these are also going to be similar because they have two angles that match, two 40-degree angles, or one 40-degree pair plus a 100-degree pair. Alrighty, so there we are, similar triangles. See you in the next one. Goodbye.